Hey, 7.3, table R, functional groups. Get this out. Basically, a functional group is anything that is added on to a hydrocarbon that's not hydrogen or carbon. So any of these you're going to notice they have oxygen, they have halides, which are group 17, they also have nitrogen. Okay, table R, we're going to talk about the halocarbons, or a halide. And a halide is anything that has a halogen in it. Halogen is group 17. So basically what you're going to do, we're just going to use butane as our example for every single one of these. So we're going to have a halocarbon that is butane. So actually, instead of drawing all my H's, each one of these represents an H. I'm going to take this short and sweet. If I have a chlorine here, this is 1-chlorobutane, because it's on carbon number 1. Now if I put it here, we're going to change the prefix. Now I have 3 different chlorines, and I need to specify where these chlorines are. So I will have 1, 2, 2, 1, 2, 2. I have 3 chlorines, so that is a trichlorobutane. You're not going to get any more complicated than that. 1, 2, 2, trichlorobutane. Now, a slight modification is I could set something up like this. Again, we're still going to have a butane backbone, but I'm going to have a 1,2-dichloro and a 2-bromo, sorry, it doesn't fit, 1,2-dichloro, 2-bromobutane. Alcohols. 1, 2, 3, 4. Again, we're going to use our butane backbone. And an alcohol, all it is it has an OH on it. It can be an OH here. This is 1-butanol. The ending is OL. So we have butane-ol. It's still an alkane, so it's going to have the AN ending, and it has an OL because it's the OH group. So this is 1-butanol. Now, I could do a modification of this, and I could change the location of the OH. If the OH is on the left side, it's not going to be an OH, it's going to be a HO. Remember, keep your H's on the left. H's on the left, O's on the right. Because it's showing that the oxygen is binding to the carbon. This is still 1-butanol. If I change it, and I put the OH here, it becomes 2-butanol. You will never experience one where you're going to have it in 2 different locations. You're not going to have 2 here, or 1 here, 1 here. There is a name for this, but you don't have to know this in high school chemistry. So again, this one right here would also be 2-butanol. Ethers. An ether, all an ether is it has an oxygen in the middle in between 2 hydrocarbon chains. So for example, this example, you're going to name it taking the shorter side first. So this is the shorter side, this is the longer side. The shorter side, without drawing all my hydrogens, sorry, I'm trying to save some time for everybody, we are going to call this ethyl, because it's an ethyl group sticking off of the oxygen. So this is actually an ethyl group, a CH3CH2 ethyl group. So it is an ethyl, and this is 3, so it's going to have the YL ending. Propyl, ethyl, propyl, ether. Ethyl, propyl, ether. Ether because it's an oxygen in the middle. Let's just say we had 2 ethyls. So instead of calling it ethyl ether, when you have something like this, you're going to use our prefix diethyl ether. Diethyl, because there's 1 ethyl here, 1 ethyl here. You can also have dimethyl, dipropyl, dibutyl. Doesn't get more complicated than that in the regions. Diethyl ether. Now, an aldehyde and a ketone at the same time, because they're very similarly related. So let's use, we're going to use an aldehyde, and we're going to use butane as our example. So an aldehyde has the double bonded oxygen at the end, can either be here or here. So an aldehyde never has a number. However, a ketone will have a number because a ketone is in the middle, and you have to specify the number of where a ketone is. So these are actually, they both have the root of butane, and this is also the root of butane, but they have a different ending. So this is an aldehyde, so it is butanal, and this is a ketone, so it is butanone. However, we need to specify which number this is. There is only one ketone for the butane, because it cannot be on the first carbon, because that would make it an aldehyde. It has to only be on carbon 2. Remember, we count from the shortest side. There is never such a thing as 3-butanone, because I could reverse it and it becomes 2-butanone. Okay, we're going to talk about esters, and this is a little bit more confusing, so I'm going to spend a little bit more time on this one and go through a few examples. I have this one right here, and if you notice, there's two parts to it. So you have the hydrocarbon that is sticking off the end, which is going to have a YL ending. And then you have the hydrocarbon that has the functional group attached to it with the double bonded O and the O in the middle. And this is going to have the anoate ending, or the O8 ending. So basically, it's going to end like that, but it has the O8 ending. So we're going to name it in segments. And if you look at your example, it'll tell you your example according to a reference table. But this one right here, so we have one carbon, which is methyl. And then here we have 1, 2, 3, so it's a propane backbone. And then we add the O8 ending. So it is methyl propanoate. Methyl propanoate. All right, so another example of an ester is I can do the reverse. Now again, when we draw this out, we have, this is the hydrocarbon that is sticking off the end, so it is going to have the YL ending, and this is going to have the OATE ending. Now when we name this, it's always easiest, guys, to figure out this part is not a hydrocarbon, so this part is not going to have the specific name. It's not going to have the YL ending. So when I name this, it is going to be propyl, then we have one carbon, and it is a methane, OATE. Propyl methanoate. Okay, our last example of functional groups are amines and amides. And all you really need to know, they very rarely ask questions about this. But, again, it's a butane backbone, butanamine. And this one, you're going to notice, they look almost identical, except this one has a double bonded oxygen. Remember, when you have the double bonded oxygen, count the bonds on the hydrogen. Nitrogens can only have 1, 2, 3 bonds because nitrogen have 1, 2, 3, 4, 5 valence electrons, which means 1, 2, 3 bonds. Oxygen has 6 valence electrons, so it can have 2 bonds. And oxygen always will have 2 bonds here, and it's going to have one appearance. So don't make this too complicated. This is butanamine. This is butanamide. Okay. Butanamide, butanamine, the only difference, this one has a double bonded oxygen and one less hydrogen. Sorry, 2 less hydrogens. Butanamine, these make up a lot of amino acids have an amine group. That's why they're called amino acids, which is a very common term in the Live and Environment course. So good luck with these functional groups. If you have any problems while you're doing your practice problems or your flashcards, consult these videos. They're very good videos. I spend a lot of time making them. Peace out.